Good day, everyone. My name is Iyliana vdeo, and today I will be presenting my project entitled From Reactive to Reliable, a TPM documentation system for a wire harness assembly, developed for a flat module syndrome Bahar industrial case study. The objective of this project is to improve the maintenance management system in the wire harness assembly production by implementing a total productive (TPM) documentation system. This system helps reduce equipment downtime, improve maintenance efficiency, and support continuous production performance. Bef- Before this project was developed, the maintenance process at the flat modules was most reactive. The first challenge was high machine vulnerability. Maintenance activities were only carried out after equipment failed, causing unexpected production interruption. The second issue was a lack of a standardized maintenance system. There was no proper maintenance schedules, documentation, or preventive maintenance record. As a result, this problem caused a frequent machine downtime, a reduced production efficiency, increased the repair cost, and affected overall product quality. To overcome this challenge, a structured TPM document system was proposed. This slide illustrates the various tools used during the harness assembly process. These include crimping tools, cutting tools, wire cutters, and wire strippers, and texting fixtures and torques wrench. All those tools directly affect wire harness quality. If any tool is damaged, worn out, or improperly maintained, it can defect and occur during the production. Therefore, proper maintenance documentation is essential to ensure every tool remains in a good working condition and consistently produce a quality product. The anatomy of unplanned downtime. This diagram explains how equipment failures develop. It usually begins with a maintenance tool, followed by gradual deterioration. If the issue is not detected early, eventually result in unexpected equipment failure, causing a production to stop. Without a formal maintenance system, maintenance becomes a reactive instead of preventive. This increase a repair cost, a cause production delay, and reduce the manufacturing efficiency. The maintenance paradigm shift. This slide compares the current maintenance practice with the proposed TPM approach. Currently, maintenance is mainly reactive. Maintenance record are incomplete inspection, are inconsistent, and operators depend heavily on maintenance technician. Under the proposed TPM system, maintenance become a preventive and systematic. Maintenance activities are scheduled regularly, and documentation is standardized. Operators perform a basic daily inspection, and a maintenance decisions are based on the record data. This shift improves equipment reliability while reducing unexpected breakdown. A strategic scope and resource utilization. The project focused on specifically on the wire harness assembly department. The scope include a tooling inspection, maintenance documentation, and performance monitoring. The project was designed with a realistic constraint including limited manpower, limited maintenance budget, and existing production schedules. Despite this limitation, the TPM document system can still be implemented effectively because it mainly improves the documentation and maintenance management rather than requiring expensive equipment. The TPM engine cross-functional synergy. Successful TPM implementation required cooperation between several departments. Production operators perform a daily inspection and basic maintenance. Maintenance technicians carry out the preventive maintenance and repair. Engineering support a technical improvement and process optimization. Management monitors performance and ensure continuous improvement. This teamwork creates a culture where the maintenance is everyone's responsibility, not only the maintenance department. The five-step implementation roadmap. Step 1 is identify the current maintenance problem. Step 2 involve creating a requirement TPM documentation. And step 3 is training operators and maintenance personnel. Step 4 is implementing TPM activities and using documentation during the daily operation. Step 5 focus on monitoring result and continuous improvement based on the maintenance data. Core TPM activities. The TPM system consists of two main maintenance activities. The first is on autonomous maintenance, where operators perform a routine cleaning, free shift visual inspection, and a day of approvals to damage. The second one is planned maintenance, where maintenance technicians perform a scheduled inspection with preventive maintenance repairs and replacement the worn component. The documentation ecosystem. The slides show how all maintenance documented are connected. Daily checklists are complete by operators. Maintenance records are complete by technicians whenever maintenance work is performed. Tooling's inventory records monitor tools condition and availability. Defect report a production problem related to equipment. Document deep dive. The front line. The first thing is tooling inventory record, which is record tools identification numbers, tool conditions, maintenance status, and location. The second one is a daily tooling checklist, a visual damage charts, a moving part function, safety condition acceptable, and valid celebration label. Document deep dive. The intervention. When a maintenance work is carried out, technicians complete the testing defect report form and tooling maintenance record. This document record of the machine condition, maintenance performed, replace component, inspection result, and technician information and completion date. This creates a complete maintenance history, making a future troubleshooting faster and more accurate. To evaluate the control dashboard, measuring success. To evaluate the effectiveness of a TPM system, several key performance indicators are monitored. These include a total breakdown frequency, number of tooling defect, maintenance completion rate, preventive maintenance compliance, and production downtime. The dashboard allows management to monitor the maintenance performed and quickly identify areas requiring improvement. In conclusion, this project successfully proposed a structured TPM documentation system for a wire harness assembly process at the flag module syndrome height. The system transformed maintenance from a reactive approach into a preventive and systematic process. With a standardized documentation, regular inspection and preventive maintenance, and performance monitoring, the company can reduce equipment downtime, improve productivities, lower maintenance costs, and achieve continuous quality improvement. Thank you so thank you very much for your attention.